The James Webb, when it was announced, they told us it was going to cost $500 million. And so they were really close because it was about $10.8 billion. Most NASA scientists knew they were just all wet. They were completely wrong. Nevertheless, that's how the project got put off. So the James Webb is different. I want you to think about this for a minute. All those pictures you're going to see tonight, and you may be seeing in the press, the spectacular pictures. The Hubble has no telescope. There's no eyeglass. There's no optics. Not the Hubble, I'm sorry, the Webb. The Webb has no optics. Hubble is a huge optic that we put out into space. The Webb doesn't do that. The Webb collects infrared data across 4 spectrums, 4 different kinds of tools. I'm going to show you that at some length. So it has these 4 instruments, and it's looking, you can see the visible light spectrum there. The James Webb is just to the right of that. It's all that infrared space. So the reason infrared is important is when you get out in space, infrared is kind of like the visible spectrum. Most things out there are in infrared, not in the visible light. The visible light is the way our sun was designed and the way God designed us to live under our sun. So we see in that spectrum, but most of space actually sees in the infrared spectrum. Not that these things see, but the energy that they emit are in those frequencies. You understand? So the Hubble was regular light, the Hubble Space Telescope, and a little bit even into the ultraviolet, which is the other end. It's going up higher, shorter frequencies. But the infrared is where the James Webb is. So the James Webb has a European instrument. There's 4 instruments on there. Each instrument probably costs about $1 billion, to give you an idea of the complexity of these tool sets on this spacecraft. And Europe made that particular one, the spectrograph. The MIRI was made by US and Europe. The US made the near-infrared object, and the Canadians actually made the 4th instrument, which is spectrography. So at the end of the day, there's these 4 very specific instruments looking for specific things on the Webb. But remember, it is not actually taking a picture. So I'll take you through how that works. So when you take the Webb and you take some of these instruments, they can look at something. This happens to be our galaxy, and this is the amount of oxygen, neon, hydrogen, etc., in various parts. So it literally can look into an atmosphere or into a space and measure each atom there. It's actually quite remarkable. So this is the composition of gas around an active black hole. This is in the Milky Way. So it's literally looking at that and measuring the amount of atomic hydrogen, how many iron ions, atomic hydrogen again in a different spectrum, and molecular hydrogen, that's something different. And essentially you can see they can depict this by the size of the wavelength of the light. This is down in the microns. I mean, this is really, really, really small. And then this is the composition of gas around the black hole in a more of a graph area. And that picture, that black hole, is in the center of something called Stephan's Quintet. We'll talk about that a little bit later. But that's 5 galaxies that look like they're all together in space. It's very close. You can see it from your backyard with binoculars. You don't need a telescope. Stephan's Quintet. Just so you know, 4 of those galaxies are actually, in space terms, close to each other. The 5th one is about 200 million light years farther back, but you can see it. It looks like it's the same there. That's because of gravitational lensing. So let me tell you another miracle about the James Webb. The Hubble, again, is orbiting Earth, and it's 354 miles out. It's in a stable orbit. So you can see the picture down below. Here's Hubble, and it's going around the Earth, and it's outside the moon. It's farther out than the moon is. The moon's about 240,000 miles away. Not the Webb. The Webb is out 930,000 miles. Now, the secularists will tell you it's 1,000,000 miles. It's kind of sexier. But the fact of the matter is 930,000 miles. And if you want to know where the James Webb is, anytime you can look at the sun, just turn around. It's 930,000 miles straight that way. And we know this because we put it there on purpose. It's at a place called L2, Lagrange 2. It turns out that there was a reasonably smart man in 1797, half Italian, half French, called Joseph Lagrange. And he determined through polynomial math, you should see the math. It's unbelievably sophisticated. Our ancestors were not stupid. Okay, they just didn't have the tools we have. But they could reason many things out, including the fact that every planet that rotates around a sun has 5 Lagrange points around it, where a small mass object can be put in a stasis orbit. And so it turns out Lagrange 2 is what's called an unstable place. That means we can't put it there and it'll just stay there. But that point that's 930,000, we can put the Webb in an orbit around it and it will stay there. So as the sun moves through space, and the sun is part of the galaxy, as the galaxy moves through space, it's dragging our sun. And as our sun moves through space, it's dragging the Earth. And the Earth and Lagrange 2, between the sun and the Earth, is essentially dragging the Webb. And the Webb is in an orbit that's perpendicular to the solar system orbit. You may or may not know this, but the solar systems are flat. This is one of the things that really drives them crazy. They're flat. It's one of the reasons Pluto got kicked out of the club. Pluto is 8 degrees off, so it's not really like the rest of the planets. The other thing about Pluto is 2/3 of the time it was a trans-Neptunian object. That means it was inside the orbit of Neptune. So its orbit was not in the concentric circles like all the rest. So in 1931, when it was discovered, they essentially brought it into the club, but they kicked it out about 10 years ago. So it's just considered a dwarf planet. That's a freebie. That wasn't part of the thing. These 5 Lagrange points are out there, and we put spacecraft, and now this is an $11 billion spacecraft. They sent out 930,000 miles away, and so you might imagine they had sent some other things out there first. So that cosmic background radiation, we sent 2 probes out there in 2000 and 2009. And those probes have been out there. They're still out at Lagrange 2. So there's 3 spacecraft there. It's going to get very busy. All those other space agencies are going to start using the Lagrange points too, because you don't get the interference from Earth, et cetera, et cetera. So the Webb weighs 7 tons. The spacecraft, the astronomy, the platform weighs 7 tons. It is bigger than the rocket that sent it up. So as you might imagine, they had to make it and then figure out how to make it articulate, right? How to make it fold. And the 2 big things on the Webb are the mirror, and you know a minor mistake on the mirror on the Hubble was really expensive. We have no means of sending anybody up to fix it. None. So we make a mistake and we send it out there, it's going to die out there without us. That's pretty much it. So this spacecraft, they had to figure out how to do that. And this mirror, incredibly huge mirror. Huge. I'll give you an idea a little later. And there are 5 solar shields on it. They're not for collecting power. That's a different set of shields. But there are 5 shields on it to help it collect and dampen light. We don't have time to go over that. But the point is, all of this, somebody described it as buying the most complex self-assemble IKEA furniture you can imagine, putting it in a box, sending it out there, and then it has to self-assemble. It has to. And so when they did this, it created 344 single failure points. A single failure point is something you do in high-end engineering. A single failure point means that if that issue doesn't work, the whole thing is done. The Apollo missions had about 180 single failure points. The object of any time you're trying to send things out is get as few single failure points as possible. 260 of those single failure points, the most in history on any project or any mission, were getting that thing to open. You can see it over time. It comes out of the spacecraft and ultimately opens that huge mirror and opens those 5 levels of sun shields. That all had to work perfectly. We couldn't fix it. It either worked or it didn't, and it did. It worked. There were people who spent between 10,000 engineers worked on this for a decade to get this right. So you can imagine the pressure of that job. So at the end of the day, there is a lot about this that's a miracle. And even the secularists, they understand they were part of something much bigger than themselves. And there's this enormous pride in a job well done, right? Took 29 days from the launch to get it out, fully assembled, out at Lagrange 2. It cost $11 billion US, weighs 7 tons, and has 344 single points of failure. Nobody in their right mind spends $11 billion on something with that many points of failure. The idea that you're going to get 344 out of 344 is pretty rare. So you can imagine that's why it costs so much, because they did everything over and over because they couldn't make them redundant and we can't fix it. So the Lagrange polynomials, this was Joseph Lagrange. He published this in 1797, this whole idea about these Lagrange points. And I'll just move on. So we have Webb way out here, following essentially the Earth, and it's looking out that way. So here's the evolution of the technology on the telescopes themselves. We have the Spitzer, which was in space. It's still out there. And you can see what Webb does compared to anything we had before. It's not even close. In infrared, they're allowed to see, or not allowed, they're able to see through all the gas. Space has lots and lots of molecular gas out there from explosions, et cetera. It's not empty. Space is not empty. So this is called the Carina Nebula, cosmic cliffs. You can see the evolution. From Earth, that's what it looks like. From Hubble, it looked like that. And Hubble, remember, was a picture. So we know this is right from the Webb. And you can see the clarity. So I want you to think about this. The Webb is collecting 4 incredibly large streams of data from 7,500 light years away and collecting it on the Webb 930,000 miles from Earth. It's then transmitted here. It is then converted or normalized into spectrum so we can see it. We can't see that data, right? So it has to be normalized, and then they can tell you the story of the cosmic cliffs. So I have one of my associates here tonight. What we do is big data. And so we can tell you a lot about what happens, for instance, in an emergency room or which doctor's doing things maybe better than others, that kind of thing. And at the end of the day, that's exactly what we do. We collect a lot of information from lots of places. That's what the Webb is doing. Normalize it into the current environment, and then you have to tell the story. What's happening? So the Hubble the optical telescope looked like this. This is a picture out of the Hubble. This was groundbreaking when this happened. And in this case, the color is a function of one of 2 things: the temperature or the distance away, the Doppler effect, right? Whether it's moving away from us or towards us. So that's the Carina Nebula. I explained that. It's 300 light years in diameter. These are huge things. This is, you've probably seen this, Pillars of Creation. It's in the Eagle Nebula. But look at how clear, this is Hubble. And Hubble had infrared on it too. That's what it looked like. This is the Pillars of Creation under the James Webb. I mean, the amount of detail we get is just magnitudes above what we were getting. That's the Hubble deep field on the left. That's what the same deep field looks like under Webb. Now you understand every one of those dots is a galaxy, not a star. You're taking a picture, usually a 1% sample of the sky, right? The sky's 360 degrees. 1%, and you're only going 1% this way too. So 1%, it's like a grain of sand. In the case of Hubble, it was like putting a dime on the end, like your fingernail. And that's the amount of space you were covering. And the first Hubble Deep Space, they did it out just, I say north, but above Ursa Major, the Big Bear, the Big Dipper. There was a blank spot there. Nothing there, right? It's empty. They took a picture. They estimate there are 500 million galaxies down that hole. Oh, by the way, to get that exposure, 10 days. They open the aperture and they run it for 10 days. So that means the telescope has to adjust for the orbit, the change in position, all of that. Fairly sophisticated math to make all this work. So when they talk about rocket scientists, it's really true. So these are new discoveries in old areas about merging galaxies, star clusters, sideways galaxies. See that one that's kind of face on to us? Looks like a UFO actually. And then clusters of new stars. So the Webb, wherever Hubble took a picture, if you go to the Webb, you'll just get that much more. And we're finding all kinds of things we didn't expect. So Hubble, Webb, again, just to give you an idea, the leap in technology is dramatic. And as a result of that, the amount of knowledge coming back is dramatic. And we made a lot of assumptions that weren't right, turns out. Hubble, told us things that weren't true. So most of these objects are in a picture spot like that. There are 1 to 2% arc of space, and it's like taking your little pinky up. That's all you're seeing. And then, like I say, there's millions of galaxies in there. And those galaxies have thousands of black holes. We thought galaxies only had one black hole. Milky Way's got thousands of them. And not every black hole is the same. This is the deep space. This was the first image that was published. And that was in July of 2022. So galaxy formation. How do galaxies form? Essentially, you start with a bunch of gas and material, and essentially they start coalescing. And then eventually the rotation, I'm telling you their theory, not mine. But galaxies apparently form of their own volition, and there's a whole series of stories. We're like 5b there, or SB. See it over on the right? The Milky Way is that kind of galaxy, a spiral galaxy. Most galaxies are elliptical, and barred spirals are like the second most common galaxy. So here's where we start running into issues. This is the picture, somebody brought it up before. These galaxies are way too mature. Remember, they think they're looking back in time. So those galaxies didn't have enough time to develop, like using their theory, like the Milky Way. The Milky Way, right, 5.6 billion years old, that means it's 8 billion years separated from the start. So it took a long time to develop into what it is. This is their theory. And now they're looking back, and if this is really a time capsule, these are only 700 million years after the start of the Big Bang. So there's not enough time. The point here, though, is you may notice some of these are red shift, some are neutral shift, some are blue shift. How in the world are galaxies moving back towards us from the Big Bang? And if you think about it, they all should be moving towards us. Why are they moving away? We're the ones that should be moving away, right? So at the end of the day, this has really confused all that theory about redshift. There's huge articles coming out trying to defend this, but the evidence just does not support, what we observe does not support many of the theories we have, in particular about galaxy, star formation, and solar system formation. These happen to be the farthest away, and you can see there's a few blue shift and red shift, and there's a neutral shift there, which means apparently the universe can't figure out if it's coming or going. So we don't know what all this means. And my suspicion is, if it's 13.8 billion years, it wasn't created there. And we didn't move. God said, as we started, I spread out the heavens. Right? I did this. He's taking credit for it. Nothing natural about it. So the galaxies are too mature, and they're too close to the Big Bang. So that's a real problem that they're working on now. The redshifts are not as predicted. And so essentially, this whole story about the inflation, when life on Earth begins, all of this is now under question. Because if you don't get the first part right, you're building on a false edifice. So problems with the Big Bang, I'm going to go over these very quickly, but these are very serious problems that the Big Bang theory does not address adequately at all. Cosmic backdown radiation and the anisotrophies are too smooth. In other words, when you see an explosion, when you see a sudden expansion, generally you're going to find things it shouldn't be uniform. It should be random, right? The background radiation is relatively smooth. It's almost the same everywhere. So that seems to argue against the theory. Uniform temperature requires matter to exceed the speed of light. I can't go into it, but the horizon problem is a big deal. And in order to solve the problem, they have to have matter moving faster than the speed of light. It's the only way to get out of their problem. And we don't think matter can do that. The universe is flat. It's called the flatness problem. That's a real problem because they think the universe is actually on a balloon, right? And then there's a multiverse. There's billions of parallel universes, etc. The universe is too large for the elapsed time. Believe it or not, 13.7 billion years is not long enough, even by their own theories, to develop what we see. And so there are quite a few theories out there now that the universe is in fact 26 billion years old, doubling the age. It's not accepted yet. There's far too little lithium and helium, way too little. In other words, their own theories require these elements to be there. They're not. They're missing. Antimatter, matter annihilation. Given their theory and given what we know about physics and quantum mechanics, you can't create matter without an equal amount of antimatter. And when antimatter and matter join, they annihilate. They wipe each other out. So it turns out that we have about 10 to the 9th power too much matter. That's what we see. That's the 5%. I mean, the theory it's really on thin ice, if you understand it. The monopole problem, we have no single-sided magnets. There's no reason that every magnet has to be positive, negative. In theory, there should be equal. This is just like the Schroeter problem in life. Every bond in your body, every one in a human being is left-handed. In nature, molecules are equally distributed, right-handed, left-handed. If you're a football player, it's like the tight end side, right? The strong side, the weak side. Molecules are like that. And you need to understand the way the universe works, almost everything works in asymmetrical, not symmetrical. Right? Electricity is a result of an asymmetry. It's a charge, one direction or another. So is magnetism. Almost every process. Almost every process is a result of an asymmetry. And so we should have monopole magnets. That they don't exist. The surface brightness, how bright we see things, actually would match a non-expanding universe. Okay, it doesn't. The brightness is wrong on these things if they're moving away from us or moving towards us. Structures are too large farther out, and dark matter, which remember is 68% of all the mass needed. We can't even prove it exists. It's a theory. All right, galaxy clusters. This is another very big conundrum. We're part of a galaxy cluster. It's called the Virgo. So the Milky Way isn't by itself. There are lots of galaxies around us. So a lot of these galaxies, you can see there, those are galaxy clusters. Now, if this all exploded out, they hate that word, expanded out, then there should be a more uniform distribution of matter. But there is not. The matter in the universe is very organized and very clumped. They call it that, the clumpy universe. So at the end of the day, here, the Milky Way is where that arrow is. Those are all the galaxy clusters that are to one side of the Milky Way, just to give you an idea. So the massive wall called BOSS was discovered by a Canary Islands-based team, and it means the baryon oscillic spectrum. Remember, baryon just means visible matter. So wherever we could detect atoms, that was put together. And essentially, that's what it looks like. The association of galaxies from this Canary Island thing, look, it looks like a spider web. Looks like some kind of web. They're very organized. And then the newly discovered BOSS wall, this is from 2021, includes 830 galaxies, including 4 superclusters. It's about 1 billion light years long, and it's not quite as big as the Sloan wall, but it has more volume. And so this is what it looks like when it gets mapped. So the Sloan wall is the largest structure ever known out in the universe, 1.3 light years long. And this is 2 degrees. This is a 2-degree field. And we're finding structures this large out there. So God says that you can tell about his power by what we see out there. So there's a star called VY Canis Majoris in the Sirius constellation. That star is the size of the orbit of Jupiter around our sun. We could fit 400 million suns of ours in that star. So just like Israel wasn't the most important country, just like we're not the most important people, God chooses. Israel's important because God chose them. God chose Earth and the sun. And I believe what you do, that it's very special, made exactly for what it is. Not because we're the biggest or the brightest or the hottest or anything else. There are structures in space that stagger the mind. And God says in Romans that we are without excuse. You can tell about his Godhead and about his power simply by what has been made. So to give you an idea of the Milky Way, can everyone kind of see it there? Milky Way is right here. That one of those walls is here, the Boot supercluster, Hercules supercluster. The Boot supercluster has 400 million galaxies in it. I mean, what's out there is just, it's beyond numbers. Like God says, we'll never count it. We'll never get it. Just like we can't count the sands in the sea. He says we'll never do it. So that's where the Milky Way is. And this is what it looks like. And the red dots are galaxies, not stars. We're talking about galaxies. And so as we look out there, the splendor of what's out there, either we have the most magnificent God. I don't know what the alternative is, actually. So there's a theory out there, I'll spend 3 minutes on it. It's called plasma cosmology. It's a scientific hypothesis. It's done by Nobel laureates. It is not well accepted. I want you to know this is not well accepted, but this would replace our whole idea of shifts, Doppler shifts. It would replace the idea of creation. And so the theory assumes no origin of the universe in time. We know that's wrong. But no inflation, no dark matter, which we can't find anyway, and no dark energy is needed. So it turns out that the James Webb is supporting most of the things that the plasma theory says. Plasma, it's a fourth state of matter. And in plasma, the electrons have shed. So the protons don't have any electrons with them. And that's plasma. On Earth, that's lightning and that's fire. Those two things are actually plasma forms of nature. In space, 99% of the known universe matches the definition of plasma. It's not what we think of. So that's an alternate theory. This is just a beautiful picture of the Cartwheel Galaxy. Look at the detail on that. It's just unbelievable. This is the expansion of a supernova 1987. That's when it was first discovered, 1987. So it has the clever name, 1987 AA. That's supposed to be an exploding star. So they've been watching it really close to see if they can understand how stars come apart. In that, hopefully learning more about how stars come together. So our sun is up here, and around us there's a bunch of stars in the proximity, space proximity, that move all in random. Things don't move in uniform around us. They're all random. And so the stars in the local neighborhood move at about 43,500 miles an hour through space. Our solar system is moving at that speed as we go through space. And so arguably, it would take us 230 million years for our galaxy or the solar system to go around the center of the Milky Way. That's arguably our orbiting thing. So the galaxy rotation, though, is much faster. It's almost 500,000 miles an hour, or basically about 18 seconds to go from New York to LA. That's the speed we're moving through space all the time. These are some amazing pictures, all off of the web, just to give you an idea what's out there. But unfortunately, for the secularist, there's an unexpectedly large number of black holes, and it looks like there may be 15 to 18 different kinds of black holes. They're not all the same. A black hole is a place where the gravity is so great that all light goes into it and none of it ever comes out. So most objects in the universe reflect light. They'll absorb light, but they'll reflect light too. Black holes don't. And so black holes are these massive, massive gravity wells. And so we find them in the center of many solar systems. There are white holes, and there's a horizon on these. And they believe the multiverse. Have you heard that term, multiverse? So statistically, you can prove that life cannot arise by chance. So that's why they need billions of planets so that they have enough numbers on that side to counteract the odds of a single protein forming by itself, that kind of thing. So we have all the big, first let me say something. Our God is a God of enormous numbers. God is not confused by math, okay? Big numbers are his domain. I'll be right with you. And so the numbers here are staggering. So the idea here is that they say that there are multiple universes. And so the odds of a life here are 1. That means certain. There has to be life here because we're here. So think about that. We've all been told you can't do that. That's cheating, right? But that's what they say. And the argument is that all of these other multiverses that we can't see, life isn't there. Life is here, and so the only reason we can do this calculation is because we're here to do it. So these are all pictures off of the web, and as you can see, galaxies, there's another thing about this. You know, no two fingerprints are the same, no two irises are the same, no two zebra stripes, no two leaves, no two snowflakes, etc. It looks like there's no two solar systems the same. I'll show you that in a minute. And no two suns the same. And so far, we've spectroanalyzed, a couple 100,000 suns, and no two are the same. They're all unique. So God has a sense of humor. Galaxies should be relatively evenly distributed. They are not. The wrong distribution of galaxy types. Most galaxies should be elliptical. They are not. Unexpected quantity and variety of black holes. So these expectations are all a result of their theories, not what we expect. Their theories. And so when we look at what we observe, it doesn't fit the theories. So what you'll find is they'll do what they do with evolution. They'll just change the theories or change the definition of words, etc. This is called the phantom galaxy. What's fascinating about this, for those of you who've been in our Fibonacci, the galaxies are organized precisely according to Fibonacci ratios. So those of you who have not seen them before, Fibonacci was Leonardo Pisa, and he published a treatise in 1204. That's right, 1204. And his presumption was that the Fibonacci sequence, which is based on whole integers on the positive side, base 10. We were not using base 10 back then. We were using abacuses and the Roman numerals. And his argument was that base 10 was how God organized the universe. In that we, if we're going to get our math right, had better move to base 10 if we want to learn what God has done. Can you imagine using that? It took 300 years for Western civilization to make the move. But this was Leonardo of Pisa, sometimes known as Fibonacci. But ancient men were not stupid. They just didn't have our tools. They didn't have our technology. They couldn't see in the microscope. They couldn't see in the telescope. They didn't have any of those things. They didn't have electricity or electronics, right? They couldn't do that. But when it came to what was in front of them, the physical world, they were every bit our equal. Every bit. A man in Egypt figured out how far the sun was away to within 1 degree in 300 BC. He did it by walking 180 miles. But anyway, that's the Hubble picture of the phantom galaxy. That's the Webb infrared. And then what you're going to find in the press a lot, that's the combined. They'll combine the digital to bring out different aspects of the picture. So you'll hear people say, that's a false picture. Not really. The Hubble is picking things up in natural light spectrum. The Webb is picking things up in the infrared spectrum. So they're both true. And when you put them together, that's what it looks like. So it's not a direct image, because our cameras can only take direct images generally in the regular spectrum. So this is galaxies colliding. I just want to remind you, God said over and over that he spread things out. I have made the earth, created man on it. My hand stretched out the heavens, and all their host I have commanded. And like it is, he sits about the circle of the earth, and its inhabitants are like grasshoppers, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. And so that's about 9 times in the Old Testament, that's why those things are so far away. Not because we're billions of years old, because God did it as part of his act of creation. This happens to be the Orion Nebula. Orion, the belt of Orion, the hunter, right? The 3 stars there. Those 3 stars are mentioned in Job 38. And God is maybe a little miffed with Job, and he says, where were you when I set the foundations of the earth? And part of his questions that he asks, which go on, by the way, for 4 chapters, he says to Job, can you loose the belt of Orion? Can you bind the Pleiades? That's the 7 sisters. It's right along the horizon most of the year for us. The Subaru logo is 6 of the 7 his sisters, because 35% of humanity can't see the 7th star. I can't see it. So that makes me in that special group, the 35%. But no, the fact of the matter is, he says, can you loose the belt of Orion? Can you bind the Pleiades? And for a couple thousand years, and in Christian literature, this was thought to be poetic. It turns out, probably not. It turns out that those 3 stars in the belt of Orion are in something called virial equilibrium. They could be there for 1 billion years, and they would look in the same position to each other. It's like somebody put them on the freeway in 3 lanes and then put on a cruise control and they can't move. They have to follow the lanes. They have to go at 70 miles an hour. And so it doesn't matter how far you go down the road, they're going to look like that. The 7 sisters, on the other hand, turned out to be an unbounded cluster. It turns out that they're just going through space together, and that's the way they happen to look now. But they're not going to look like that later. This is like putting 6 teenagers, or 7, on the freeway and letting them go wherever they want to go. And, you get 10 miles down, they're not going to look like that. Now, this is really fascinating for us because the 7 sisters have been found on ruins. So Celtic ruins, like at Stonehenge, or in the Lacage caves in France. Those stars are in roughly the same position we see them. Those ruins cannot be older than 7,000 years, neither can the stars. Can't be. And so in many of those places, those signs have come down. And so I'll go back to Job. Can you loose the belt of Orion? No chance. God put them in virial equilibrium, and there is nothing you can do about it. And the Pleiades, can you bind them? Can you put them in virial equilibrium? And God is just telling them, look, I'm God, you're not. Okay, and there's useful information there. And so things we thought Scripture was musing about isn't a muse at all. God was speaking very directly about the difference between God and not God. So that's the belt of Orion. This is the color of that, and you can see with the web, we can see through the clouds quite a bit. This is a deep space image, pretty spectacular actually. This one here is close. It's about, if I remember, 200 light years away. Some of these are as far as 8 or 10,000 light years away. Same image. So you open it up and it just starts collecting light from this little part of the sky and just goes deeper and deeper and deeper into space. The secularist believes they are looking back in time. So they've discovered a clump of ancient galaxies. We've talked about it, stuff that we've never seen before. This is 4 images. Now, this is, before I showed you the Phantom Galaxy with Hubble and Webb, this is 4 telescopes. The Webb, the Chandra, which is in the ultraviolet, the Hubble, and the Spitzer. And so these are all looking at different aspects of the energy, the information coming from the energy of these. And this is what they look like when they start combining them. But this takes a fair amount of technology and know-how in literally billions of dollars. So at the end of the day, our solar system is like this. We have an asteroid belt. It's incredibly important. And then we have the Kuiper belt, which is out past Pluto most of the time. Pluto's out beyond it once in a while. And that's our solar system. In the solar system, one of the principal things is the asteroid belt. And the asteroid belt is that white stuff. But there's a group that's outside of the asteroid belt. It's considered part of the asteroid belt, but it's influenced by the Jupiter's orbit. It literally follows Jupiter. And so we have what are called the Greeks, the Trojans, and the Hildas. And they are literally following the orbit of Jupiter. Jupiter gets hit by an asteroid or something. The point is that Jupiter's our great protector. About 3-4 times a year, something massive goes into Jupiter. If something comes inside the asteroid belt, the sun usually takes it. So Earth is in this bubble. It's a gravity bubble. And we're protected by the asteroid belt, driven by Jupiter on one side, and we're protected by the sun on another. So that's why asteroids generally don't hit us. Now, if you read Revelation, I think there's going to be an exception to that. But at the end of the day, it turns out this is pretty important. And if you get a chance, about a month ago, some amateur astronomers saw something hit Jupiter. And you'll see it on the web. Just put it in YouTube or something. And it shows up as a huge flash on the surface. So if I go here and I look in scale, our rocky planets are right there. And then you got the asteroid belt. Then we have the gas giants. They're trying to do this to scale. Then we've got this Kuiper belt. And then ultimately there's this thing called the Oort cloud outside of that. So it gives you some idea. Oh, and by the way, there's some things called dwarf planets. Pluto's now a dwarf planet. And they're found in the asteroid belt and the Kuiper belt. those two places. So how did our solar system come to be? A lot like the galaxies. A bunch of dust, gas, etc. It starts accreting. It pulls together. As it pulls together, the gravity increases, pulls even more in, essentially. And ultimately, you end up forming planets around this, yeah. So having said that, you need to think of our solar system. It is flat. We do all circle the sun in the same direction. So maybe there could be some kind of cyclone, you might imagine. But then that would mean that all of the planets and all the moons and everything should go in that same circle, right? But the problem we got here, Venus is rotating the wrong way. Venus rotates the other way from all the rest of us. Most of us are counterclockwise, Venus is clockwise. Uranus is even worse. Uranus is rotating on its side. And it turns out that 2/3 of the moons of Saturn and Jupiter are going the wrong way. I'll show you that. So at the end of the day, there's another thing, and that's the Oort cloud. I'll show you the Jupiter thing in a minute. The Oort cloud is supposed to be out there, and this is where the long cycle comets are supposed to come. So if you think of that thing in the middle, that's our solar system, and this Oort cloud is this enormous number of objects, trillions of objects that are out beyond the edge of the solar system. And the reason they need this is to explain comets. Comets can't be billions of years old. There is no mechanism that you can make a comet billions of years old, because every time it goes near the sun, it gets smaller. Every time. So there's a limit to how old comets can be, and it's generally considered to be 10,000 years, even by the secularists. So where do short cycle, long cycle comets, and in particular, long cycle comets are comets with more than 200 years. We only see them every 200 years. They go outside of the solar system, go where they're going to go, and then their orbit brings them back in 200 years later. Halley's Comet, you may remember, was 76 years, right? Mark Twain was born when it came and when it left. So, the idiots out there think he came on the comet and left on it too. So, I shouldn't say the idiots. There are people who believe that, sorry. But these long cycle comets arguably come from the transition. So there's theoretically trillions of objects outside of our solar system. The only issue is here that neither the Hubble nor the James Webb can find any evidence of it. So this is another rescue device. Just like dark matter, dark energy, we can't find it. You need it as a plug to explain something that your theory doesn't cover. These are called rescue devices. And we have lots of them in our theory, cosmogony theories, about where things came from. So at the end of the day, we believe the Oort cloud is just another attempt to avoid the conclusion that God made these things. And it's all relatively young. So we're going to talk about planets, James Webb on the planets. So they turned it not from far away and new. These are all new pictures. And these are pictures of these planets. And they are way better than the pictures we had in the past. And so Saturn, from Hubble, that's what it looks like. From James Webb, it looks even more spectacular. We can actually see a huge storm on the northern hemisphere of Saturn. You can't see that in Hubble. You need infrared. But that's an ammonia vapor storm, and the winds are about 1,000 miles an hour. And ammonia vapor stays in the atmosphere in Saturn, as far as we can tell, for decades after a storm. It doesn't clear. So anyway, that's when looking in a different spectrum. If we were looking in the infrared spectrum, we'd see this, but we never saw this before. These are the rings around Saturn. I mean, that's just a spectacular picture, no matter how you slice it. This is another picture of Saturn, and here's the moons of Saturn. So as of 2021, Saturn was in second place for the number of moons. It had 82. In August, James Webb Space Telescope discovered another 62 moons around Saturn. So Saturn is now in first place, beating Jupiter. But what I want you to notice up there is that it's very faint, But see the blue lines? Those are the lines that correspond to the theory of solar system formation. Those would be prograde moons with the right orbit based on the nature of the energy, they're saying, created these things in the first place. But most of Saturn's moons are in fact what are called retrograde, and they're almost perpendicular. So they're in the wrong plane and they're going in the wrong direction. That's what the red are. And then, just to add insult to injury, because I believe our God has a huge sense of humor, he puts a couple, they're green, they're going in the opposite direction. This is like releasing a couple of drunks on the freeway going the wrong way. Not a good thing. And so they can't be billions of years old. Statistically, you cannot drive things in the opposite direction in the same plane and not collide. So from Lagrange 2, these pictures, and from the observatory in Mauna Kea, my wife and I have been there, there are some pictures of the Saturn moon Titan. And in the top, there's two cloud areas. They showed up in both pictures, both the Earthborn and the James Webb. The issue is, this is what the news said. So you're reading this article, and it says, NASA's Webb telescope has peered into Saturn's moon Titan, which is also the only planetary body other than Earth that has rivers, lakes, and seas. What would you assume from that? Water, right? Except it's not water. It's liquid methane and ethane. Water can't possibly exist there. It's about minus a zillion, I don't remember the number, minus 179, minus 290 Fahrenheit. And so that's what they do. They give you this impression. We found water. They didn't find water. There are liquid things that look like rivers and lakes, but liquid methane doesn't have much to do with water, and it certainly has nothing to do with life. And this is the way it's being communicated to your kids and to grandkids. The Hubble shows the stuff on the left. On the right, you'll start seeing the rings. Every planet, every gas giant has rings, all of them. Turns out Earth actually has rings too. It's just they're widely dispersed ice particles in space, but there are places. And our astronauts have known this for years. They go through it every once in a while. But it's widely dispersed ice crystals, so it doesn't do any damage to our craft. This is from July of this year. That's Jupiter. That spot over there, by the way, is bigger than the Earth. That's a storm that's been on Jupiter as long as we've been able to observe it. Carbon was detected on Europa, moon of Jupiter. So you're supposed to assume, right, you're carbon-based life. Got to have carbon. Without carbon, you don't have life, not like we know it. And so they found carbon. So they leave the impression that this carbon, but unfortunately, this is atmospheric carbon, which is not the same as coal in the ground. Carbon, okay? And so at the end of the day, another kind of misdirection. And so here is our Jupiter story. So Jupiter has 3 sets of moons. They have the Galilean moons. They're called Galilean moons because that's what you could see through the telescope that Galileo had. That's what we thought was the moons of Jupiter. We find out later that there's a prograde group, that's the blue. The Galilean moons are inside, they're kind of a cranberry color. Don't show up well on the screen, but the Galilean moons, and I don't remember how many there are, but like maybe 20. And so that's what Galileo could see, and that's what we thought. The prograde group, prograde simply means that the moons are moving in the same direction as the planet is spinning. That's what prograde means, and that's what should happen if the theory of solar system formation is right. That's what you would expect to see. But see how many moons are retrograde? That means they're moving the wrong direction. They're moving against the spin of Jupiter. And just like Saturn, God has a sense of humor, and he's put a couple of new prograde in the path of the retrograde. And on Neptune, I didn't include it here, there's just 2 moons, and they're in the same plane and they're going in opposite directions. Same thing. Can't do that very long without colliding. So when we look at Uranus, that's the picture out of Hubble. When you look here, James Webb can detect 13 rings. So that's what I was telling you, that a lot of what's in space we can't see using the spectrum of light that we see through our eyes or through optical instruments. We have to use digital collection instruments in different wavelengths. And we start seeing all kinds of things that are there that we couldn't see before. That's a picture of a moon of Uranus, kind of amazing. The moons of Uranus. Neptune, these are pictures of Neptune, different pictures, Voyager 2, and then Hubble and Webb. And these are Neptune's rings, a close-up. And then Triton. One of the moons of Neptune orbits the planet backwards. And so astronomers are completely befuddled by that. So the part I didn't get to, I'm going to summarize in 5 minutes. So they've been looking for exoplanets. You'll see that word. An exoplanet is a planet that is not in our solar system. So they're looking for planets in other places because they need planets to be there that hopefully have water and they're habitable so they can prove that their theory of evolution is right. Because you need to understand the fundamental theory of evolution here is now got homogeny and what's called convergence as its 2 key points. And homogeny means because it looks the same, it all came from the same place, which, by the way, we agree. We just don't interpret it the same way they do. But convergence says that nature has a purpose. They will never say that. But there's a natural result. When something needs a wing, a limb, a fin, those are all homogenistic structures, and nature will come to the same conclusion multiple times. It's called convergent evolution, and they've been teaching your kids this for about 20 years. And what this means is when they go to the fossil record and the inner ear bones, which they believe came from the jaw of a reptile millions of years ago, your inner ear bones, which are a miracle, absolute miracle, they will say that it evolved 8 different times in mammals, that it kept going extinct, and so we still had this need for the middle ear bones in a mammalian hearing structure, and so at the end of the day, they'll say it'll come up over and over again. So all they need is one planet or one moon where they can demonstrate life arose, then convergent evolution is right, evolution is right, we're not alone in the universe, and directed panspermia is right. Man is here as a result of the aliens. Aliens came here, and it was Watson and Crick who found the DNA double helix that came up with that. So there's quite a bit on exoplanets. I will tell you, one of the prize exhibits I had was a picture in one of the kids' high school books about these exoplanets. You know, beautiful planets, all this stuff, right? At the end of the day, we have one picture of an exoplanet, and it's a smudge. But what they do is they'll use these artist renderings and then come up with their story. And it's all presented like it's a fact. And so you just need to be aware of this for your kids and grandkids. So I really appreciate your time. I'm going to close in a word of prayer, if that's all right. Heavenly Father, thank you so much for this evening and our ability to get together and talk about your creation. The heavens truly do declare your majesty, your glory, and it really is a wonderful thing to serve a God like that. Lord, I just ask you to bring these things to mind as we meet with our secular friends, and they need to understand our testimony about trusting you, that it's not a blind faith, that there really are sound reasons that you've given us through what we observe in the universe for our faith in you. So I just thank you again for bringing us together, and I pray all these things in Jesus' name. Amen. Take a few questions.